Hi everyone. In this session, we are going to discuss electric field intensity. We are going to derive an equation for electric field intensity. Name of chapter is Electric Charges and Fields. This is part 8 video. Objective of this session is to learn equation for electric field intensity. We are going to derive it. So before starting the discussion, let us revise something. Previous knowledge. Electric field intensity. It is the force experienced by a test charge placed at a particular point. That is electric field intensity. Coulomb's law. Force of interaction between two charges is directly proportional to product of the charges and inversely proportional to square of distance between them. We have discussed these things in the last classes. According to Coulomb's law, what is equation for the force? F equal to 1 by 4 pi epsilon 0 q1 q2 by modulus of vector r square into unit vector r. And we have discussed one more equation for force in the last class. What was that? It was F equal to Q into E. For finding force, there is one more equation, charge into electric field intensity. Let us start the discussion. We are considering a charge here, it is Q. This charge is Q. We are going to find electric field intensity at a particular point near to this Q. We are going to derive an equation for that. Okay, so what we are going to do here, we are going to find electric field intensity at this point. At this point, we are placing a test charge. Do remember what we need to do? We need to place a test charge here. This is test charge, it is Q0, Q0. Distance between these two charges, it is R. So here you can say the distance. The distance between these two charges, it is R. Now let us write it. Consider a charge Q. This is charge Q. Let the electric field intensity is E at a particular point. At this point, the electric field intensity is E. Okay, at this point, we have placed a test charge here. At this point, the electric field intensity is E. Place a test charge Q0, Q0 at that point. We have placed a test charge here. So this you need to write before starting the derivation. Okay, there are two charges. You can see two charges here. One is Q and second one is Q0. And the distance between these two charges, it is R. Okay, now because of this charge Q, there is a force on Q0, right? According to Coulomb's law, what is equation for force? 1 by 4 pi epsilon 0 q1 q2 by r square. That is equation for force. Here we are considering only magnitude. We will discuss direction at the end of this session. Okay, so first we are considering the magnitude only. The charge Q0 is experiencing a force. According to Coulomb's law, what is equation? There are two charges, Q1 and Q2. Equation for force according to Coulomb's law is 1 by 4 pi epsilon 0 q1 q2 by r square equal to F. Here there is no Q1 and Q2. Here it is Q and Q0. So what would be the equation? Force on charge Q0. It will be F equal to 1 by 4 pi epsilon 0 Q into Q0 by r square. Here there is no Q1 and Q2. Here we have Q and Q0. So equation will be F equal to 1 by 4 pi epsilon 0 Q into Q0 by R square. Because of this electric field intensity, there is a force acting on this test charge Q0. What is that? So we are writing that equation also. Equation is F equal to QE, charge into electric field intensity. Here the charge is Q0. So what would be the equation for that? Force on charge Q0, it is F equal to Q0 into E. F equal to QE is the general equation. Here it is F equal to Q0 into E. So we have two equations for force. The force is same because these two equations are for force only. The force acting on the charge Q0, it will be same. So we can compare these two equations. LHS are same, then RHS should be same. So we can compare this. So what will be the equation for that? Q0 into E equal to 1 by 4 pi epsilon 0 Q into Q0 by R square. Just we are comparing. LHS it is same, then RHS should be same. Here you can see that Q0 is common. In both sides Q0 is there. So we can cancel Q0. So we are cancelling Q0. Then E will be equal to 1 by 4 pi epsilon 0 Q by R square. That is the equation for electric field intensity. When we are considering the direction, you need to consider the direction of force acting on this test charge. If the force acting on the test charge is in this direction, that will be the direction of electric field intensity. If the force acting on this test charge in this direction, then that will be the direction of electric field intensity. Direction of the electric field intensity will be the direction of the force acting on the test charge. So if you want to find the direction, you need to find the direction of force acting on the test charge. That's all for today. In the next class, we are going to discuss electric field intensity because of system of charges. Thanks for watching.